Hello everyone, welcome to the 7th part of the video tutorial series Learning Pandas from Zero. My name is Shane Chileung, and in this tutorial I will be your guide in Pandas. Today we will explore together how to process data in the data frame in the column level. In this chapter we will focus on textual data. Let us recapitulate what we have learned in our last tutorial. We have covered how to make query about numerical data and process them collectively. We have learned how to make query based on single or multiple conditions. We have covered how to use the default function to change all data along a column collectively. We have also shown how to use self-defined function and a masking function to apply changes to the existing data. Now we will do something more. In this chapter, we will introduce two concepts. First, we will demonstrate how to use condition to filter the data frame so that you collect rows which satisfy the specified conditions. Second, we will cover both the built-in methods for string operation and how to use self-defined function to change the textual data. Since this chapter is about text, we will introduce a new data frame to work on. This time your friend brings you a new data frame. Let's take a look at it. It is a contact list of some staffs, together with their ID, location, email, and their programming languages. In this chapter, we will be making query and operation based on these data. For textual data, most of the skills we introduced in the previous chapter can be directly used. The query format is identical, namely you type the name of the data frame, square bracket, inside the square bracket you put in the conditions. Most features we have covered can be used, such as the method isIn, greater or less than, equals to, and so on. Notice that when Panda compares the values of strings, Panda is comparing the ASCII values. Here I show you one example in how to use the method isIn to do the query. We first type df square bracket, inside the square bracket, the condition, and we want to find the entries where the location is either AU or UK. So we write df column location dot isIn, and then we pass a list containing two elements AU and UK as argument. And then Pandas returns 3 entries. We may immediately compare it with the original data frame and confirm that it is the correct answer. For strings, there are more native methods available in Python which can be used directly in Pandas. They are stored in the module called str. As I assumed you have some basic understanding about Python, so I believe these methods are quite familiar to all of you. Some of the useful ones are match, contains, methods which check the types of characters such as is upper or is lower or start with or ends with. The usage of these functions should be readily understood by its name, so here I will only briefly describe its applications. In the left example, we show the method contains. This method tries to find in a string whether it contains the phrase you provided as an argument. If yes, then this method returns a Boolean true value. Here we want to search from the email column which entries contain yahoo.com as the domain. And Panda returns us 4 entries. When we look at the original data frame, indeed, they are the staff who use Yahoo for the email. Notice that when we use the string method, we need to call the str module first. So when we use the method contains, we write str.contains. In the right example, we do another query by the start with method. We ask Panda to give us the subset data frame where the location starts with U. And from the original data frame, this means staffs with a location from UK or US will be returned. Indeed, the result confirms our expectations. Now let us do an exercise to strengthen our query skills. Your friend wants to make more query about the data frame but not sure how to do. Can you help your friend? This time there are 2 tasks, so feel free to pause the video to think about the answer. Notice that there are multiple solutions. Let's compare our solutions. For the first one, we can use start with or contains. In general, when we ask course ID contains A, naturally we use the method contains to do the task. But notice that we also have the pattern for the ID where the letter comes first. So we can also make good use of this pattern and use the method start with to do the filtering. In the second problem, it is a filtering by composite conditions. So we just need to specify both conditions, and remember we need to use bracket to contain each of the condition, and the AND symbol to connect the two conditions. Having discussed data query, now we proceed to discuss how to change the textual data. The first thing we can do is to arrange the data frame according to the criteria you provide. We can use the method sort values. We need to pass the column headers as the compulsory argument. We can pass more than one columns. Pandas will compare the values more than one column when there are repeating values. In the first column, it compares. There are optional arguments such as axis, ascending and in place, and so on. Most of these require no further explanation because the names tells their respective options. Here we show an example. We use the sort value method to generate a new data frame called df2. We sort the original data frame by the column language. When we look at df2, indeed now all data is sorted according to the language. After that, Pandas preserve the original sequence by the row value. Notice that for operations which change the original data frame, we need to ask ourselves we do it in place or not. Because sometimes the original data frame contains the sequence we need to preserve. In that case, we need to use another variable to store the new data frame. Here we show an example of finding the entry by iLook 0. Originally, it corresponds to the person called ebook. Now, if we do this command, Pandas returns us the entry for Belinda. So we can see that the original sequence of the data frame is completely changed. We can also use the built-in method to efficiently convert the textual data. Some of these should be very familiar to all of you, such as link, replace, upper, lower, strip, and so on. Again, their functionality is identical to the native one, except that it can apply to a column instead of an individual string variable. The first example is to extract some statistical feature of a string, one of which is the size of the string. We can directly use it on a column of the data frame. Notice that whenever we use this string-related methods, we need to write str. First. After that, the method name. Then Pandas will return a series based on the processed column. The second example we want to show is the replace method. It is a very common operation for cleaning the textual data, so I would like to make an example here. This time we want to change all emails ending from .com into .net. To do so, we call the method str.replace and pass the pattern to be replaced, namely com as the first argument, and in the second argument, the new string pattern we want to override, namely net. Notice that we cannot use in place here, so we need to specify the target column where the new data will be stored. Since we want to change the original data, we use the original column to store the result. Indeed, now the data frame contains email which all ends with .net. Another powerful method for changing text is certainly the apply method. The apply method allows you to pass your self-defined method to Pandas. First, it has less constraints in the complexity of the operations. Again, I remind that the apply method only takes one argument. So if you need to pass multiple arguments, please refer to Chapter 6 for the details. This time, let's do something of larger scale. We want to build a column for the branch of each staff. The branch name is taken as follows. It takes the location and language in small letters. For the language, we only use the first 3 characters. Then we connect the 2 strings by a hyphen. For example, for a staff in UK using Python, then his branch name is UK-pyt. Let's take a look at the code to see how it works. We first define a method called getFirstFreeChar. Justified from its name, it means it returns the first 3 characters from the input argument string. We first use the default method lower to the location column and store it as the variable prefix. Then we do the same for the language method and then pass the apply method to the output series to extract the first 3 characters. Then we store the result in the variable suffix. Finally, we form a new column in df by doing column operation. Namely, we concatenate the 2 columns as if they are string variables. Now let's exercise and see if you have grasped these important concepts well. This time your friend has a challenging task and does not know how to tackle. Can you help your friend? This time your friend's company wants to build the email address automatically for all staffs. The email address is derived from the following rules. It starts with the initial of the first name, then it is the full last name, and then the first 3 characters of the programming language they use. The 3 segments are connected by hyphens, and finally the domain name is yahoo.com. There are many steps here, but all the skills are well covered in this chapter. Again, feel free to pause the video for giving you some time to think about the answer. Let's take a look at the code. This time I must say the scale of this exercise is the largest among all the 7 chapters. I hope you have no problem challenging it. We first need to define 2 methods, to extract the initials and to get the first 3 characters in upper letters. To extract the initials, we use the split method on the column first name and form a series called names. This will give us a series. Each element is a list containing the partitioned first name. Then we loop over the list and extract the first character and form a new series called initial. After that, we use a similar technique for the column language. Notice that in the method extract first 3 chars, we use the method upper to convert the string to all capital letters. Finally, we concatenate all strings together by treating all series as string variables. Then when we output the final data frame, we indeed have the results we want. So that's the end of our 7th tutorial video. And once again, thank you for watching this video. I hope to see you again in the next tutorial. We will learn how to use Pandas to do indexing and merging multiple data frames. Again, practice makes perfect. I will encourage you to also read my open source ebook to do some of the related exercise to strengthen your skills. I hope you have enjoyed the tutorial today. See you.